Right. Good afternoon. Welcome to our third, fourth, third or fourth session.
Utombotaura uchimbomira uchida utombotaura nyaya yako.
We're going to continue where we left off. Last time when we were talking of complements, and why there is a need for complements in logic design. I think the main reason is the need to deal with the arithmetic process, dealing with subtractions in number systems. Right. Today, we just finish up the first set of topics according to our course outline, where we talked of the number systems and all that. I think this is just the last part of that first set of topics. Then we'll move on to part two, which is Boolean algebra. So I think, given 3 other sessions will be done with part 2, 3 other sessions, part 3, in a month's time, we'll probably be done with the whole course. Then you have like 2 months of the rest of the semester to revise, to prepare for the test, prepare for the practicals. You do have practicals. We are going to conduct practicals. And if I can remind all of you, you need to attend those practicals. You need to attend, you need to participate in the assignments. I think I mentioned there's a new rule. In fact, the rule was already there, but they were not implementing it. But this time around, we are implementing it. Because personally, I feel 50% is too much for coursework and practical work. That's a personal thing. Because you copy and paste a lot. So there is no need to put 50% on practicals and assignments. So because of that, if you do not submit your work in time, there is no leniency. From me personally, from everyone else, probably you get that. But I feel 50% is too much already. So if I become lenient after that, then why are you doing engineering? I don't know. So be very careful on issues of practicals and assignments and tests. I think once we are done with the first part, there's probably a test coming. You need to be ready for that one, which include everything we did on the number systems, the complements, the conversions, and all that stuff. It will probably be conducted on Google Meet. I think someone gave me that idea instead of using ELMS, because most of you will not be registered by then. So we'll be using Google Meet, and everyone will write the test, even if you didn't register. Now, on issues of complaining data and everything, no, we cannot do the test now because data. Well, ladies and gentlemen, we are moving into a period where you will probably never attend physical exams, especially these small ones, the assignments and that other stuff. We are online learning. We are online learning. When you register, you know that we are online learning. So when you come to me and give me an excuse of you don't have data, it will not amount to anything. It will not amount to anything. I understand things are tough, but you Need to make a plan, ladies and gentlemen, because data is everything right now. Data is everything. I think 1 gig of data is 60 bond. Sacrifice. Do everything for that 60 bond so that you attend these lectures, so that you attend the exam, the test, because they'll be scheduled like a week before. You know you have a test on Monday, and in the morning you are crying data. I think it will not amount to anything. That's a personal thing for me. I know things are tough. Even for me, I was complaining earlier on. They're tough even for me. But you did register. We are online learning. That is not an excuse. All right. Now that we have that out of the way, we begin. We ended up with complements. Now we're going to codes. We have a number of codes which are used by the computers, which are used by the digital systems. All right, the ones which will concern us in this course, we have what we call the BCD, binary coded decimal. We have the gray code, and we have XS3 code. Those three, you need to know what are they. So basically, the BCD, we have what? The BCD. We have the BCD, which is the binary coded decimal. So this binary coded decimal is basically the same normal binary system we know, but each decimal digit being represented by 4 bits. So for decimal normal binary BCD, 0, 1, 2, 3, 4. 0 is 0 for binary, 1 is 1, 2 is 1, 1, no, 1, 0, 3 is 1, 1, 4 is 1, 0, 0. This is the normal binary system. For BCD, it is represented by 4 bits. I think I tried to put out this point when we were calculating complements, when I ended up adding zeros, and I said there should be 8 numbers and that stuff. It comes from here, these codes. So for 1, we have 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, until you get to 9. 9 is 1, 0, 0, 1. This is the BCD, the binary coded decimal. These are the codes. So for example, if you have a number, let's say 329 in base 10, and you need to represent it in the BCD code. What you do, each decimal digit, 1, 2, 3. There are 3 decimal digits there, 3, 2, and 9. Decimal digits, they go from 0 to 9 only. Decimal digits, they go from 0 to 9. So each decimal digit is represented by 4 bits. So BCD representation, you take 3. We have 3 here. Is that 3? No, 3 is this one. So 3 is 0, 0, 1, 1. 2, 0, 0, 1, 0. Then we have 9, 1, 0, 0, 1. This is called BCD. This is not binary system, the normal binary system. The normal binary system, 329, will probably not be the same with this one. The normal binary system, 329 to base 2. If we are to move this to base 2, let me do this. Redo base 2 x base 2. It is not the same as the BCD. I think you get a completely different creature if you try to find the 329 to the binary system. Right, so this is the BCD representation. Each decimal represented by 4 bits. Example at upper, there are 329. 3 is represented by 4 bits. 2 is represented by 4 bits. Then lastly, 9 is represented by 4 bits. Right. I just got 329 binary here. 329 binary is let's just see this one. Right. So 329 base 10 to BCD is 00113 00101001. Then base 2 binary. Base 2 is 101001. Is this the same thing? 00? Nope, it's not the same thing. So you see BCD in the normal binary system, they are not the same thing. This is binary. They are not equal. So that's it for BCD. BCD, it has how do I put it? It has parts, components. We have BCD 8421. We have BCD 2421, I think. But we will only be using this one. But in case you meet with this type of BCD 2421, what it basically means is instead of having 8421 for each 111, I think I introduced this. If I have 111, how do you find what is the value here? You say 8 because there's 1 plus 4 plus 2 plus 1. This one, it will be 2 plus 4 plus 1. It's just a different system. There is another one which starts with 5. I'm not sure how it ends, but they are all BCD systems. Right, we will be using this one, 8421. Right, we also have the gray code. The gray code, just a minute. Right, to continue. I said we have BCD, we also have gray code. Gray code, this is a code with minimum changes when we move from one code to another. Minimum changes. This code is minimum changes used in error detection. Error detection. Now, what does the gray code look like? What the gray code looks like for the whole set of numbers, binary numbers, we have 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 0, 0. This is 0, 1, 2, 3. So this is the normal binary system or the BCD. Now, what does the gray code look like? The gray code, it has a simple formula. Either you can claim. I know some of you, they are very good at claiming. You can claim the numbers. Or you can claim the numbers, or there's a formula for that. The formula is MSB doesn't change. MSB doesn't change. Then the next one, which is MSB minus 1, You get a clear picture later on. For now, just follow through. MSB minus 1 gray is equal to MSB XOR MSB minus 1 binary. Now MSB minus 2 gray is MSB minus 1 XOR MSB minus 2 binary. Then lastly, MSB, let's just say MSB minus N gray is equals to MSB minus 1 minus N XOR MSB minus N binary. Right. If we have 4 numbers, 4 bits, for example, 0, it's 0, 0, 0, 0. This is in binary. This is your most significant bit. This is MSB minus 1. This is MSB minus 2. And here we have MSB minus 3. To get the gray code, there's a message. Please provide login and password. I gave login and password. How do I find it? If anyone with ID and password, I think I gave it to some of the students there. Please forward it to all. Please forward it to the group. Login and ID. I'm sure it's on the description of one of the groups. Please forward it to the group so that we can copy paste and show others who are unable to log in. Right. Where were we in Africa? So I was saying this is the MSB minus 1, MSB minus 2, MSB minus 3. There we have it, ID. Forward it in, Brandon, forward it in the group if possible. Forward it in the group. I'm sure the student will see it in the group. Right. Now, how do you find the gray? How do you find the gray code? How do we find the gray code? The MSB doesn't change. What is the gray pattern of this one? The MSB doesn't change, which means our MSB gray, it remains the same. This is binary, this is gray. What is MSB minus 1 gray? The next one. It is MSB XOR MSB minus 1 binary. When we talk of exclusive OR gate, let me introduce what this XOR is. This is the exclusive OR gate. What it basically means, if you have 2 numbers A and B, 0, 1, 0, 1, 0, 0, 1, 1. If you have a gate which is XOR, anyone to help me participate? XOR gate. What are the outputs of XOR gate? XOR gate. Anyone?
I think
0, 1, 1, 0. Right. I was waiting for you to respond. This is XOR gate. What it means is if you have 2 inputs which are both low, or 2 inputs which are both high, then the output is 0. This is XOR gate. So in our case, can I do this? In our case, just a minute. In our case, where we had 0, 0, 0, 0, this is a binary, gray, We said MSB doesn't change. The next one is this number, XOR, this one. Or we start with this one, XOR, this one, then this one, XOR, this one, then this one, XOR, this one. So 0 XOR or XOR 0 is 0. 0, 0 is 0 here. Coming from. So the gray code remains the same for 0, 0, 0. We can do this for the rest. 1, 2, 3, 4. Let's go to the fourth one. 4 is 0, 1, 0, 0. This is 4 in binary. How do you convert it to gray? The first bit, the MSB, it doesn't change. It's 0. Right. The next bit is this one, XOR this one. 0, XOR 1, it is 1. The next bit is this one, XOR this one. 1, 0, it is 1. The next bit is this one, XOR this one, it is 0. So this is the gray code. 0, 0, 0 for 0 and 0, 1, 1 for 4. There are others with methods on how to interpret the gray code. Other methods, if you have those other methods, okay, fine with me. You can use those. In an exam, you can get something like convert a certain binary number into gray code. If you know it by head, you've crammed it, you can just put it there. If you don't know it, that is the formula to use. Right. Now, this is the gray code. This is the gray code. So it goes from 0. Let me see. For those who want to claim, you can as well Google it. 0, 1, 1, 0, 0, 0, 1, 1, 0, 0. It continues like that. Then we have 0, 0, 1, 1, 1, 1, 0, 0. Then third one we have 1, 2, 3, 4. 1, 2, 3, 4. The last one, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. This is the gray code. It is not the same as BCD. So this is 0, this is 1, this is 2. But 2 in binary is 0, 0, 1, 0. This is binary. It is not the same as this one. Now I'm feeling I've spent too much time on this course. Let's move on. So we have the binary, the BCD, where each decimal number is represented by 4 bits. We have the gray code, where there is a minimum change of only 1 bit between 2 numbers. So if you notice, when we say there is minimum change of only 1 bit between 2 numbers, if you notice, when we move from 1, 0 to 1, only 1 bit changes. This last one. Can I be more clear here? Let me see. 0, 0, 0, 0, 1, 1, 0. Right. So this is 0, 0, 0, 1, 1. Here we have 4 zeros. 1, 2, 3. 1, 2, 3. This is the gray code. When we talk of only 1 change, when you move from 1 bit to another, here, when we go from 0 to 1, there is only 1 bit change. This last bit, it changes. When we move from here to here, this bit changes from 0 to 1. Here we change from 1 to 0. Only 1 bit changes. When we move from here to here, only 1 bit changes. This one changes from 1 to 0. It goes like this and it continues like this. And this is the characteristic or a property of the gray code, which is used in detecting errors. I think we have time to get into that later on. Binary codes, gray code, the access code. The XS3 code, XS3 code. You can Google that one and claim it on your own time. Because I feel I've spent too much time on this one. Right, this is it for codes. You need to know these codes. Because as we move on, you see, we'll be asking you to design a circuit which converts binary numbers to gray code. Because in digital systems, not all systems use the BCD number representation. Some use the BCD, some use the gray code. But when they need to communicate the two systems, what do? You need to provide a circuit which converts between the two systems. So you will be asked to design a circuit which converts between the two circuits. So you need to know both codes or the codes which we'll be using. And I said in this course, we'll only be focusing on three: the BCD, the gray, and the XS3. And that's it on these codes. Right. Questions, comments, before we move on to the part 2 of our course. We are done with part 1. Any questions concerning part 1? Part 1, it had number systems, number conversions, complements. Any questions? Yes. Brandon.
Last time, I think there was a error the most significant bit sign ya 0 ndiye anenge ari first 0 anenge ari positive, then 1 anenge ari negative.
Okay, I saw that group somehow. I'm just realizing that I didn't respond. Now, where did you get that information?
Google.
Google. Bit sign and representation. I think both vice versa, it can work as well. It depends on how you defined what your 0 is and what your 1 is. So from Google, the representation of sign in the binary is commonly referred to sign magnitude. And if the sign bit is 0, the number is positive. And for me, it was negative. Different sources, but I think the idea remains the same. Even if I exchange between the two, depending on how you defined your system, then it's either negative or positive. But for now, I'm telling you, it's me who defined this system for this logic design group. It is me who defined it. So you will use 0 negative, 1 positive. Don't get that confused.
Okay, sir.
Yeah, but I think if
sir.
I define the system 0 positive, 1 negative, or vice versa, if I know what is the definition of the system, then it will definitely function the same way. If I see a 0, I know by the way I define mine is a negative. If I see a 0 in front. But the one who designed the one I'm seeing here is vice versa. I'll verify. The source I used, we are going to stick with it. Unless or otherwise. Right. Any other questions and comments? 10 minutes. Concerning first part of the whole course here, number systems, number conversions, complements, and codes. Comments and questions, because we are done. Next thing is test assignments. Nope.
Sir,
Yes.
is it possible? Okay, I can.
Okay,
recorda kuti vamwe tinoshandisa data patoda kuti revisit tingoshandisa mavideos atakasevhera not kuti ne Google Drive kwenyu.
You need to be allowed to record.
Yes.
Okay, the next session I'll allow you to record.
Right.
Well, there is a thing with the recording though. When I record, I remove the parts I don't want out there. like the ones I talk of my salary and stuff. Now, when you record, everything will be out there. That's the issue. That's why I choose to record. But I do allow you to record. I think it will put some bounds on what I say. All right. Any other questions? I think that's it.
Yes, sir.
Chat. Yes, Rafa.
Is it possible to get questions whereby you'll be asked to add or subtract BCD numbers?
Yes, you'll be asked. Now it's up to you to know how to manipulate that situation. You know how to add binary numbers. I introduced you to 1 + 1. The next thing I'm going to give you X + Y. Now that is your job to find out how do you add X + Y. You get the point? Because
Okay, thank you, sir.
BCD, yeah, BCD is basically binary. I taught you how to add binary. How do you add gray now? That's another issue. That's the X + Y. That's why you need to learn. That's why you need to research. Even me too, I also want to record and do this. Okay, I'll allow everyone to record. Is it possible? I'll see if it's possible to allow everyone to record. And that's it for the first part. Now we move on to the second part of our course, which is Boolean algebra. I'm going to end this session. When I resume, we'll start with the Boolean algebra. I'm out.